Alrighty, gang, let's do this test. Alright, start. Make sure you put your bloody well name on it. So let me do my name. Make sure I've got the pen on. Done. Okay, so first question. Sketch the following graph on the set of axes labeling the intercepts below. X squared plus y squared. So where the center is obviously going to be at 0, 0. Because there's no h and no k number. Now this number here tells us what the radius of the circle is. Remember, it's r squared, so the radius is going to be 4. So our 4 corners are going to be 4 there, 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 and there. So our circle is going to look a little bit like that. Oh, that's a really bad circle. But anyway, right, so your circle will obviously be a lot better than mine. As we move into the next question, state the domain and range. Well, the domain is just the x values that we have. So for this particular rule, the x values that we get go from -4 out to 4. So the domain, and we include -4 and 4 because that's just the two edges of the circle. So our domain is from -4 to 4. Our range is all the y values we get from our domain, and those values also happen to be from -4 up to, 4, not 5. So we get from -4 to 4, and the range is actually going to be the same thing, as it turns out, -4 through to 4. Question 2. Tick. Where is it? Question 2. Tick the appropriate, oh God, where did we go? Yeah. I don't even know what just happened then. Alrighty, place a tick in the appropriate box to show the sign of the trigonometric value. So sine 165. So I'm actually going to go to my graph and say, right, 165 degrees, that was what it was, wasn't it? 165 degrees, that's about 150. 165 is about there. Now, is sine positive or negative there? So if we look across, sine is a measure of the y value. That is definitely positive. It's going to be roughly 0.3 by the look of it. I don't know exactly what it is, but it is going to be positive, so it's not going to be negative. What if I cos 225? Where is 225? 225 is right there, and cos for that one extends right up to be negative. It is negative root 2 on 2 exactly, actually. So 255, make sure we get this right. 255 is about there, but as we can see, cos is still negative for that one. So that one's going to be negative, and tan of 295 degrees is just before 300. So it's going to be about there, which means our tan value at the extension will, of course, be down here somewhere. It's also going to be negative. It'll be roughly -2, somewhere around the mark of -2. So that one will be there. That's that question done. Okay, I'm just going to go back to my graph and rub this out because we may need to work on this a little bit later. So let's just get rid of those bits. All my crummy drawings are gone. Almost all. Okay. Now let's go back. Radio. So next question. Scroll down. What are the exact values for the following? Okay, cos of 90. Let's go back to the graph again. Where is 90 degrees? It's up here. Cos is a measure of the x-coordinate. So the x-coordinate up here is 0. So cos of the x-coordinate there is 0. So cos of 90 will be 0. Tan of 45. Find 45 degrees. Follow the tan line up. It's 1. Sine of 270, where is 270 degrees? All the way around to, oh, there it is, down the bottom. And the sine of that is the y value, is the y coordinate, so it's going to be -1. -1. Sine of 30, so where's 30 degrees? 30 degrees is there, sine is a measure of the y coordinate again, it's +1/2. So sine of 30 is 1/2. And cos of 150, where is 150? It's all the way out there. Cos of that is going to be -root 3 on 2. So this one will be negative the square root of 3 over 2. There's 5 easy marks if we know how to read off the circle. Right, question 4. Use the cos graph below to show the approximate value for cos of 120 degrees. Well, all we have to do here is find where 120 degrees is, which is about there, and read off the cos value, which is -1/2, which is exactly what it is if you look at the circle as well. What if a cos of 50? If we look at cos of 50, it's right there, And that value there is somewhere, if we just rub that little dot of mine out of the way, that value right there is somewhere between 0.6 and 0.7. I'd be going 0.64. 0.64 is going to be the approximate value for that. And the next one we're asking is, what is x when cos of x is equal to 0.7? So I just find where 0.7 is, which is 0.7 is right there. So it's going to be, let me rub out my cos 50 circle for a second. So cos of 7 is going to be that angle there, and if we continue this right across that line, it's going to be that one. Oh, I missed. Let's rub that circle out and do it properly. And that point right there, and those angles are going to be, if we scroll that down, about 315-ish, and this one's about 45-ish. So it's approximately 45 degrees or 315 degrees, or actually we could even say and 315, because both of them have that particular cos value. All right, next question. Draw a sketch of 2x plus 1 on the axis below. Label the coordinates of any intercepts and one other point together with the equations of any asymptotes. So firstly, the plus 1 tells us where the horizontal asymptote. This is an exponential graph, so it just has the one horizontal asymptote. And that horizontal asymptote is going to be along here. So I'm going to draw it. Done. Rightio. Now, what about now we've got to go through. So we've got to label our asymptote. Y equals 1. Done. Label the coordinates of any intercepts. So let's find our x-intercept. We're not going to have any x-intercepts because this is a positive graph. The A number here is positive. So it's going to be above the line. It's never going to cross the x-intercept, but we can find a y-intercept. So y equals 2 to the power of 0 plus 1, which just equals 2. So our y-intercept is going to be there. We have to label one other point. So I'm going to choose my point. You can choose any point you want. I'm going to make x equal to 2, just to be different. If x equals 2, then we're going to have y equals 2 squared plus 1, which is 5. So the point 2,5 will also be on the graph, and that will be that point there. So this graph is going to come in and go up like that. Of course, if x equals 3, we should get exactly 10. So that's gone perfectly along the spot. And we've labelled our asymptotes, we've labelled everything. Label the coordinates of any intercepts and one other point. So we better put our coordinates in here. You've got to remember to do that. 2, 5 is there, and 0, 2 is there. There we go. Now I've got my full marks. There are many of you who are really naughty at labelling intercepts. Okay, for this question. For this graph, let's just scroll it down a little bit. There we go. Go up a bit. There we go. Write down the equations of the asymptotes of the hyperbola. So the asymptotes are here. So at x equals -2, because it's right there, and at y equals -1. State a possible equation for the hyperbola. Right, a possible equation doesn't have to be the exact one, but we know that x is -2. We know that y is -1. So we also know that the way the hyperbola graph works is it's y equals a on x minus h plus k. And in this case, our h is going to be -2 and our k is going to be -1. A could be any number. The reason this question says a possible means we don't know what a necessarily know what a is going to be yet. So let's just make it 1 for the sake of argument. So we could have a graph that would be 1 on x plus 2, because the minus with h being -2, x minus -2 is plus, and then the k number is -1, so -1. That would be one possible equation for this hyperbola. But now using our equation proves that the x-intercept is at -1, 0. So how do I find an x-intercept? I make y 0. I'm going to do that. I'm going to get 0 equals 1 on x plus 2 minus 1. And we're going to try and work that out. So let's solve this. Take 1 onto the other side. Here we get x plus, my bad, x plus 2. And then that leads to, if I swap them around, we get x plus 2 has to equal 1. Which means x equals -1, which is what we were asked to prove. So we've proved that -1, 0 is our x-intercept. Next question. Sketch the following graph on the set of axes below, clearly labelling the point of inflection and y-intercept as coordinates. Notice it hasn't asked for x-intercept. Okay, So where's the point of inflection? Where's my H and K number for this one? This time my H number is 2, positive 2. My K number is positive 8. So my intercept is, my point of inflection is going to be at 2, 8. It's going to be, oh, that's not right. It's going to be right there. So that particular point is going to be perfectly horizontal. Right, this is a cubic, right? And can we find the y-intercept? Actually, it's probably better to find the y-intercept straight away. So let's do that. Yeah, y equals, the y-intercept is going to be 0 minus 2 cubed plus 8. That's going to be negative 2 cubed plus 8, which is negative 8 plus 8, which is 0. The y-intercept is 0, which means it goes through the origin. So what does this graph look like? Well, it's perfectly flat at that region, but then it goes down through the intercept, and it's going to do the same thing going up. So it's going to be something like that. Don't forget to label our point of inflection and our intercept. Done. Perfect graph. They look kind of weird, cubic graphs, because when you try and even draw them to scale, they look very, very, very steep. All right, question 8. Next question. State the transformations that have occurred to go from 1. So if we started with this 1 graph, what are each of these numbers doing? We've got to work out what is the minus sign doing, what is the plus 4 doing, and what is the plus 3 doing. And we're going to use the language of transformations. So the plus 4 and 3 shifting it left and right, the actual word for that is a translation. So the plus 3, we'll deal with the plus 3 first. The plus 3 transformation is the graph has gone, in fact, we'll do the negative sign first, because you should always do the dilations first. We'll do the translations last. That negative sign is simply reflecting the graph in the x-axis. The same thing what happens with y equals x squared. If I do it over here, y equals x squared, and then y equals, if I add a negative in front of that, I lost my graph. There it is. If I add negative x squared, if I tried to graph those, x squared just looks like that. Of course, the negative x squared makes it upside down. It reflects as if the x-axis is a mirror. So that's a reflection in the x-axis. That's the first one. The negative sign there just makes a reflection in the x-axis. The other two are going to be dealing with these numbers. The plus 4 down there is actually, if you think about how the h numbers and the fact that it's usually a minus, the h number would be negative 4. So that is going to shift the graph 4 units. Rub out this squared stuff. It's going to shift the graph 4 units to the left. So the language we would use, that you could say shift 4 graph. You can get away with saying shift 4 units to the left, but the formal language is it shifts 4 units in the negative x direction. That's what the left basically is. So if we were to do that, it's going to shift, so the graph ordinarily would have looked like, without that plus 4 would have looked like that. Now with the new one having the asymptote down there, and the plus 3 of course is going to be up here, so a new graph is going to be there. It's shifted 4 units to the left and 3 units up. So there's a translation of 4 units in negative x and a translation of 3 units in positive y direction. And that would be the 3 marks for that one. So just basically stating what those numbers are doing is when it asks for what the transformations are. Last one, question 9. Find the exact value of the side labelled H. Right, so this is just basic Year 9 trig. So if we're going to do this as a Year 9 SOHCAHTOA problem, SOHCAHTOA, this would be a sine question. So sine 30 equals H on 13. But we know what sine of 30 exactly is. If we go back to the circle, where is sine of 30? 30 degrees is right there. Sine of 30 is exactly 1/2. So if we go back, we know that that's exactly 1/2 equals H on 13. Oops, 13. So we can actually work out what H is, multiply both sides by 13, and we get 13 over 2 equals my H value. So the exact length is exactly 6.5. Rightio, next. Cool, that's the end of it. So let's do part B. All right, the equation of the curve that would result, well, let's put my name at the top of part B. Done. So, question 1. The equation of the curve that results from that being translated 2 units to the right and 1 unit up. So remember our situations for our standard form are y equaled some number x, so we're going to go with 3. 3 to the x minus h plus k. Now, 2 units to the right means h will equal 2, and 1 unit up means k will equal 1. So what would the new rule be? It will be y equals 3 to the power of x minus 2 plus my new k number, because it's been shifted 1 unit up, my k will be 1, so it goes up to 1, and therefore my answer will be D. Question 2. You may hear Gabriel crying outside, but if you do, it's his problem. Right. Kevin buys a car and predicts that it would depreciate in value according to the following equation. In this equation, the car would be worth V dollars after N years. The value of the car after 5 years is closer to, all we've got to do for this one is literally substitute 5 in for N and use the calculator, which we should probably get up. Let's get the calculator up. Mathematica. And work out what that is. So if we get Mathematica up and running, and it takes a second. Yes, open the welcome screen. Thank you. New document. Alrighty, so what was that rule again? That rule was 40,000 times 0.85 to the power of 5 is what we're interested in. So 40,000. So we're going to try and work out what 40,000 times 0.85 to the power, and we're going to find my power button, to the power of 5. And if we, oops, we work now, we have to shift enter for that one. How are we going to do that? I'm not sure how we're going to do that actually. We can't just press enter, no. Nope, that's not doing it either. I don't know how to press shift enter on the tablet form. Just to rearrange my computer. Shift enter. There's Gabriel in the background. You can probably hear him carrying on. We get 17,748.2. So that answer is going to be 17,748. There it is. Option C. Yep, back into tablet mode. Okay. Question 3, which of the following statements would be correct? All right, we just need to go, for this one, just need to go through the graph. Is cos of 60 equal to cos of 210? Well, 60 degrees is here, 210 degrees is down here. Do these two values, if we get rid of all the other ones, do these two values have the same cos? And they clearly don't. One's on the left and one's on the right. So it's not A. Let's go and have a look at another possibility. What about sine 10 and sine of 100? Well, 10 degrees is about there. 10 degrees is about there, 100's up there. Do they have the same y value? They clearly don't, so it's not B. What about cos of 20 and cos of 340? Well, 20 degrees is about there, 340 is about there. Do they have the same cos, the same x value? Yes, they do. That'll be our one. So it's going to be C. If we just go through the other ones, cos of 30 and cos of 210, well, 30 degrees is there and 210 degrees is all the way over here. They have positive and negative. They're not going to be it. And the last one, sine of 30 and sine of 300. Well, 30's up the top, 300's down the bottom. They're definitely going to be different. So it's definitely C. All right. Question, x minus 2 squared at times x plus 1 is an equation for, right, it's a power 3 graph because it's going to have 3 intercepts. Right, and where are those intercepts going to be? They're going to be at positive 2 and negative 1, and is going to be a cubic graph. So it's a cubic graph because the power is a power 3. There's an x squared from the first bracket and another x in the second bracket is a total of x cubed. So it's going to be a cubic graph with intercepts at positive 2 and negative 1. So a cubic graph, positive 2, negative 1, C is our option. Question 5. The domain and range of that. Okay, so this is one of those weird forms of a circle. If we have a look at a circle, got a bit of space to write this up actually. Let's have a look at what a circle looks like in its formula state. So y equals, y, it's not that at all. It is x squared, x minus h squared actually, plus y minus k squared equals r squared. Now, I'm going to actually rearrange this and try and get the y on its own. So, picture that Gabriel's really crying in the background. He must have stepped in something. Right, okay, so y minus k. I'm going to try and get that on its own. Oh, not minus y. Y minus k squared equals r squared minus x minus h squared. And if we then wanted to take a square root, we'd get y equals the square root of, or y minus k, I should say, equals the square root of, let me just get rid of that and make that a bit neater. So y minus k equals the square root of r squared minus x minus h squared. Right, bear with me, don't forget when we take a square root, we've got to remember plus or minus. After that, we just get y equals plus or minus the square root of r squared minus x minus h squared and plus k tacked on the end. So what do we got here? This expression here is an expression for a circle where the plus and the minus lead to the top half and the bottom half of the circle. So if we have a look at this particular example up here, 25 minus x squared, the r number is 5, that's the r squared, and the x minus h, well in this case the h number equals 0. And the fact that there's no plus on the end means the k number is 0. So this should be a circle that exists with the centre on 0 and 0 and with a radius of 5. So let's actually draw that. Right? Let's draw that circle. The square root, without notice it doesn't have the plus or minus. So let's go to Mathematica and let's plot that. Right? So we're going to plot the square root SQRT, oops, got to do it in capitals, SQRT square root of 25 minus x squared, and we're going to graph that for x between, let's go between negative 10 and 10, and let's have a look at our so-called circle. Oh, I'm going to try and get this scaled as well. So if we go between 0 and let's make the plot range 10 too, so you can see what's happened to our circle. Plot range is going to be from 0 to 10 as well. Oops. Close the brackets, start the brackets. There we go. Oh, that's not really handy either. Anyway, it's half a circle. I can't quite get the scales to work perfectly, but we're looking at half a circle. So how do I get the second half of the circle? Well, what would happen if I did negative square root? The negative square root, now if I do my plot range properly, from negative 10 to 10, the negative square root gives me the bottom half of the circle. So how could I get both of them? So there's the negative, the positive is the top half of the circle, and the negative is the bottom. Negative is the bottom half of the circle. So the plus and the minus together make the full circle. So when we go back to our question, this question is talking about the top half. So what you could basically do is open Mathematica and plot 25 minus x squared root 25 minus x squared, then look at it, which is exactly what that is. Got to get this. Oh, for some reason that's decided to come up. Okay, so get rid of the negative and graph it and say what is the range? What are the y values we get for this? And they are from 0 to 5. So our answer, my top screen on square roots up. So our answer is going to be, our range is going to be from 0 to 5. So it's going to be one of these two. What is the domain of this graph? If we go back, what are the x values we get? Well, they go from negative 5 there through to positive 5 over there. So we're definitely, our domain is from negative 5 to 5. That makes our answer E. All right, let's move on to the next. I'm going to do a special video about half circles and the plus or minus, which I will send you guys as well to have a look at. Okay, next question. A certain type of bacteria grows according to that equation, that ugly equation, 3,000 times 2.6 to the power of t, where n is the number of cells present after t hours. So how many bacteria are present at the start of the observation period? Start of an observation period always implies that t equals 0. So if I make t equals 0, I get this will be 3,000. Commas in the wrong spot. 3,000 times 2.6 to the power of 0, which by the way we know is 1. So it's just going to be 3 grand, a nice easy mark. So determine the number of bacteria net present after 1 hour and after 2 hours. So all that's going to mean is I need my t to equal 1 and my t to equal 2. And if we go back to that, we will get, if we try and put that in, it's 3,000 times 2.6 to the power of 1, and I'm only putting the power of 1, we don't need it, 7,800. So it's going to be 3,000 times 2.6 is 7,800. The next one is going to be 3,000 times 2.6 squared, because that's what the 2 number is. If we go back to Mathematica and work out what that is, it's 20,280. 20,280. Question done. There's an easy couple of marks. Second one, sketch the graph showing bacterial growth over 3 hours using the axis below. All right, we've got several values to work with here. Firstly, where is the asymptote? Well, this is an exponential graph. It's not 2 to the x or 3 to the x. It's a stupid 2.6 to the x. So there is going to be an asymptote at 0. So we've got to make sure we put that in place. Now, if we put that in place, there's going to be the asymptote there along y equals 0. Right? Label axis intercepts if they exist and the endpoints of the graph. So because we're looking only for the first 3 hours, we're going to go from 0 to 3. Now, when x is equal to 0, or when t is equal to 0, y was 3,000. So 3,000 was about 10,000 is there, so 3,000 is there. I'll label that point as being 0, 3 grand. And then we've actually worked out the next two. So t equals 1 was 7,800. So let's pop that in. 7,800 is about there. 20,000 for question 2. 20,280 was about there. So lining up with somewhere around there. That one's lining up about 7,000. And 3, we just have to do 3 now. Do 3. What will 3 be? 52,728. 52,728. So 3 is going to be somewhere up here at 52,000. So the graph looks something like this. Now that 3, because we're drawing only over a 3-hour period, we actually finish at 3. So that is also an end point. So we've got to label that coordinate as well as being 3 and what was it? 52,000. 52,720. 728. Next question. Okay, now using your graph or an equation, let's see if we can get that question up. There it is. Predict how long it will take for the bacteria to treble from its original size. So what was its original size? Its original size was 3,000. So we want to know where 9,000 is roughly going to be. So let's actually work away. 9,000 is going to be about there. I'm guessing somewhere about 1.3 years. That's using my graph. Right? Can I actually work this out by hand properly? Well, we can, because the equation is y equals 3,000 times 2.6 to the power of n. And if I want that value to be 9,000, do I divide both sides by 3,000? That will equal 2.6 to the power of n, which means 3 equals 2.6 to the power of n. And if you remember your log stuff, this way, that means that n will equal log to base 2.6 of 3, which we can actually make up. It should come close to 1.3. Log, if we try and do that one, log of base 2.6 of 3 is 1.14. So there you go. The actual number is about 1.14. Not 3, but either way, if you used your graph and showed that working, that would be perfectly fine based on the graph. But it's actually a lot flatter than that. All right, next question. Oh, end of test. There must be a question before that. It's not sure if you can still hear Gabriel carrying on in the background, but I sure as hell can. Okay. Right, a positive cubic function has intercepts there, there, and there. Write a possible equation. Right, so this is the cubics we're talking about that have the intercepts. So this is going to be 3 sets of brackets. So the first one, x as 1, is going to be x minus 1. That's going to be the first one. The next intercept being at -2 is going to be x plus 2. And the third one at 0, 0 is actually going to be x minus 0, which we can just write as x. So often we'll actually put that at the front. So x minus 1, that would be a possible answer to that. So next question says, another point 232 is also on the curve. So don't forget that there's also a possible a number in here. So what we've actually got is y equals a times x minus 1 times x plus 2. All right. Another point 232 is also on the curve. As a result of this extra information, write the full equation. So that's actually asking us to find a. So if we were to go and try and do that, all we've got to do is substitute 2 and 32 into this equation. So 32 equals a times 2 minus 1, which is going to be 1, times 2 plus 2, which is going to be 4. Looks like an 11 there. Let's get rid of that line. And that 4 is pretty dodgily written as well. Times 4, which is 2 plus 2. So 32 equals a times 8. So a equals 4. So our equation would be y equals 4x, x minus 1, x plus 2. That endeth the test. I just got 100% because I'm a fool. I will catch you guys tomorrow. Happy studying. I'm going to put some other videos for you to have a look at too about the half circle stuff and also about just getting comfortable with the language transformations and things like that. All right, gang. I will see you guys tomorrow. Good luck in the test.